Good morning, and welcome to the second of three videos on section 1.4 in your textbook, which is entitled Functions. Now, today we're going to start right off with example number 3. And again, these examples are right out of your text. But you're asked to find each function value for the function g of x equals negative x squared plus 4x plus 1. So if the value here is 2, then g of x, g of 2 in this case, becomes equal to negative 2 squared plus, whoopsie daisy. Oops, I went the wrong way, sorry. Hang on. I have a very sensitive mouse. 4 times 2 plus 1. Now, 2 squared is obviously 4, so this becomes negative 4 plus 4 times 2 is 8 plus 1. Well, negative 4 plus 8 is 4, plus 1 is 5. And so g of 2 is 5. Now, g of t is a little bit different because obviously there's no number here. All right, but don't be fooled or dismayed by this, because all we have to do is take the original equation and plug in t anywhere we see x. And so this is actually easier, in my opinion, than an arithmetical kind of work. All right, so it's negative t squared plus 4 times t plus 1. And that's it. That's the answer. All right, there's no number answer for this particular example. And the same thing is true for g of the quantity x plus 2. This becomes negative x plus 2 quantity squared plus 4 times x plus 2 plus 1. Now, what we have to do first here is take this quantity, and x plus 2 times x plus 2 is x squared plus, right, then we're going to do the FOIL, first, outer, inner, last. So 2 times x plus 2 times x, we'll add those to get 4x, plus 4. Now, 4 times x, of course, is 4x, and 4 times 2, of course, is 8, and plus 1 is just plus 1. Now, this becomes negative x squared plus negative 4x. Now, why did I make this negative? Because of the negative sign over here. All right, 4x or 2x plus 2x is 4x, but we have to make it negative because we're multiplying the whole thing by negative 1, minus 4. All right, so that's the end result of this original term, plus 4x plus 8 plus 1. And then if we go and simplify this, obviously the negative 4x and the positive 4x go away, and I'm left with g of x plus 2 equals negative x squared plus 5. All right, and so there is the answer to that one. Whoops. There's the answer to the second one, and here's the answer to the first one. Okay, so there are our answers for example number 3. Okay, so let's have a look at the next example then, which is example number 4. It asks you here to evaluate the function when x is equal to negative 1, is equal to 0, and equal to 1. Now, this is what we call a piecewise function. all right? Because we're doing this in pieces. Ugh, come on. And so if the value of x is less than 0, in other words, a negative term, then we're going to use this equation to define f of x. If x is greater than or equal to 0, then we're going to use f of x equals this equation. So if x is equal to -1, 0, or 1, then f of x is going to equal what? Well, in this case, -1 is obviously less than 0, so we're going to use the top function. -1 squared is 1, plus 1 is 2. And so there is, so f of -1 is 2. Now, if x is 0, then we use the second equation. X is 0 minus 1 is going to be -1. So if x is equal to 0, then f of x is -1. And finally, if x is equal to 1, again, we're going to use this one. And so 1 minus 1 is 0. Okay, so if x is equal to 1, f of x equals 0. All right, and that, my friends, is example number 4. Okay, one more. Now, in this case, you're going to be asked to find all real values of x such that f of x is equal to 0. All right, and so what we're going to do essentially is say that 0 equals -2x plus 10. All right, now this becomes a matter of algebra. All right, first thing I'm going to do is subtract 10 from both sides. And that's going to give me -10 equals -2x. And then I'm going to divide both sides by -2. And that's going to give me 5 equals x. All right, so if f of x equals 0, x equals 5. I'm going to do the same thing over here. For b, I'm going to say 0 is equal to x squared minus 5x plus 6. But in this particular case, what I need to do is factor this equation. And so I'm going to say 0 is equal to, in this case, then, x minus 2 times x minus 3. All right, this is the factoring bit. All right, because -2 plus -3 gives me -5, and -2 times -3 gives me 6. All right, it's probably may have been a while since some of you have actually done factoring. All right, so let's start thinking back to those 9th, 10th, 11th grade math courses, maybe even last year. I'm not certain. But in any event, now what I do is I take these two terms and set them each equal to 0. So if 0 equals x minus 2, if I add 2 to both sides, I get 2 equals x. And over here, if 0 equals x minus 3, then I add 3 to both sides, or subtract -3 from both sides, and I get x equals 3. Okay, and so in this case, for example B here, if f of x equals x squared minus 5x plus 6, then x can, and f of x is equal to 0, then x can either equal 2 or 3. Now plug those numbers in, by the way. If we come up here, if x equals 5, then -2 times 5 is -10, plus 10 equals 0. That is correct. Here, if x is equal to 2, 2 squared is 4, minus 5 times 2 is 10, so 4 minus 10 is -6, plus 6 is 0. Bingo. And if x is equal to 3, 3 squared is 9, minus 5 times 3 is 15, 9 minus 15 is negative 6, plus 6 is 0. So again, they all work out. All right. Now, for example number 6, let's look at two different functions, f of x and g of x. And here you're asked to figure out what values of x allow f of x to equal g of x. And so in this case, for part A, I'm going to set x squared plus 1 equal to 3x minus x squared. Okay. Now, in this particular case, I'm going to combine the like terms. The first thing I'll do is add x squared to both sides. And so I have 2x squared plus 1 equals 3x. And then I'm going to subtract 3x from both sides and get 2x squared plus, whoops, that should be negative, minus 3x plus 1 equals 0. Then I factor this, this term, and in this case, crying out loud, it's going to be equal to 2x minus 1 times x minus 1. Okay, and if you think about this, all right, 2x times x is 2x squared. 2x times negative 1 is minus 2x. Minus 1 times x is minus 1x. So minus 2x plus minus 1x is minus 3x. And then negative 1 times negative 1 is positive 1. All right, and so in this case, now I can say 2x minus 1 equals 0. So 2x equals 1, or x equals 1/2. Or I can say x minus 1 equals 0, or x equals 1. So here and here. So x for part A, x could either be equal to 1/2 or 1. All right, and if you go back to the original equation and plug these numbers in, you will find that indeed this is true. Now, let's try the second one here. X squared minus 1 equals negative x squared plus x plus 2. All right. In this particular case, I'm going to subtract x squared from both sides. And so that's going to give me negative 1 equals negative 2x squared. And that's going to equal, or plus x plus 2. And then add 1 to both sides, and that gives me, whoops, negative 2x squared plus x, and if I add 1, it becomes plus 3. Now, I can do this in a couple of different ways, but 0 in this case is going to equal negative 2x plus 3 times negative x plus 1. Whoops. And if you do your arithmetic here, negative 2x plus 3 equals 0. And in the interest of space, I'm going to do this quickly. Negative 2x equals negative 3, or x equals positive 3/2. over here, negative x plus 1 equals 0. So negative, crying out loud, negative x equals negative 1, or simply x equals 1. Okay, so there are your two answers for this one. Okay, and so that, my friends, is example number 6. All right. One more little piece of, actually the only piece of information in this video, is going to be that of the implied domain. Okay, an implied domain is the set of all the real numbers for which the expression is defined. Okay, now just as a practical example, if you're trying to find the area of a room, like if you look at the room behind me and I wanted to find out the square footage of the floor here, all right, I could not put a negative number in this case because you can't have a negative area. All right, and obviously the room is bigger than 0 square feet, so 0 would not be practical either. All right, but in terms of algebra, there are two conditions where you end up with numbers that provide an exception to an implied domain. For example, you cannot have a 0 in the denominator of a fraction. All right, and so for example, if you were to plug in the value x equals 2 here, what would happen? Well, x squared is would be 4. 4 minus 4 is 0. What's 1 over 0? Well, 1 over 0 is an undefined term. All right, and so you can't have a value in this case of x being equal to negative 2. All right, and so x is not equal to negative 2. You can also never have a negative value under a radical sign. All right, there's no such thing as the square root of a negative number, and so therefore you can't end up with negative values under the radical. All right, the radicals, by the way, don't really translate in PowerPoint. There should be a line, obviously, over the x. Now, what does this have to do, or what does this mean for us when we're trying to do an actual practical mathematical example? Well, the answer here is this, that it will provide a domain with exceptions. All right, and so that's what we're going to do in example number 7. All right, find the domain of each function. Well, in the first function, obviously, the domain is going to be simply a list of all the x values: negative 3, negative 1, 0, 2, and 4. That's fairly easy, right? If there are no other points in this scenario, then that's the domain, just the values of x that we actually see in this set of numbers, or this set of points. For the second one, however, we run into an issue. We've got the divisor here, so this is 1 over the quantity x plus 5. All right. Now, generally speaking, we'd want to plug in any value for x. But if you think about it carefully, you'll realize that there's one value of x that's going to make this not a defined term. All right. If I plug in the value of negative 5 for x here, then I'm going to end up with an undefined term. And so my values for the domain are going to be all x such that x is not equal to negative 5. All right, and so there's my domain. All right, and that's how I would write it. Okay, all x such that x is not equal to negative 5. Now, for part C, this requires really just a practical knowledge of what volume means. All right, the volume of a sphere, the formula for the volume of a sphere is 4/3 pi r cubed. All right, but all right, think about a sphere. All right, for example, a tennis ball. Okay, as long as the value of the radius of this ball is a positive number, I'm going to get a volume. But if I plug in a negative value for the radius of this sphere, it's going to be any negative number cubed is again a negative number. Can you have a negative volume? No. All right. And so in this case, the domain is going to be all r's, all values of r, such that r must be greater than 0. All right, it can't be 0 either, because then there wouldn't be a sphere. There would be no volume. Okay, so all r's such that r is greater than 0. Last but not least, all right, we've got d, which is h of x equals the square root of 4 minus 3x. Now, I cannot have a negative number here. All right, and so in this case, the domain is actually going to be a number such that the quantity all x such that 4 minus 3x is greater than 0. All right, easy peasy. All right, you don't have to calculate the value of x here. What numbers would do that? Although we could do that. It would be negative 3x is greater than negative 4. And so x has to be greater than 4/3. Okay. And so that would be the, we could also write it as x is greater than 4/3. But that's an extra step and not one that is necessary. You can simply write the domain the way that we've done right here. All right, all x such that 4 minus 3x is greater than 0. Okay, so that is the end of the second of 3 videos on section 1.4, and I hope you learned something.